Hi, this is Mrs. Alexander, and in this short video clip I'm going to show you how to use Excel to create a blood spatter graph. That's a graph showing how your height and your blood diameter correspond for activity 116. First, you need to find Excel on your computer. Do that by clicking the Windows button in the bottom left-hand corner, right here, and then use the Start menu to select Excel. Once you have Excel open, go ahead and choose the blank workbook. Alright, now that we have Excel open, this may be some of your guys' first time ever working with Excel, maybe not. We're going to follow these how-to steps. These steps are located in your laboratory procedures, and the first steps involve which cells, A1, A2, B2, to use. So we're going to start here, and it says leave A1 and B1 blank. Start with A2 and B2. You want to go ahead and enter your heights and your blood spatter into these two columns. Under A2, you're going to enter your heights, and under B2, you're going to enter your average blood drop size. This is going to be the data that you've collected from your actual blood spatter lab. So you won't have that data yet unless you're doing this after the fact. So I'm just going to put some general data in there, not necessarily relevant to the lab, just to kind of show you how it makes a graph. So in the first column, I entered a range of numbers between 10 and 200. Where did I get that range? Well, in your guys' labs, you decide what height you're going to measure blood spatter from. The goal of entering this data is to end up with a chart, like shown here, that has a y= formula, scatter plot, your axis label. Based on the lab that we did, you need to look in the lab and find out how tall Anna was. Convert her height into centimeters, and you should get something around 162. You also need to measure the furniture in the crime scene. In our specific case, the table at our crime scene was 80-ish centimeters tall. Why are those two numbers important? Because with some of the assumptions you made, you may not need to measure blood from all 100 through 300 centimeters in the lab. You might only do a certain range. Now on the left, diameter of the blood drops, you won't know what those numbers are until after you've collected your data. So let's put some hypothetical information into our Excel format as well. So as you can see here, I've entered some numbers ranging between 2 and 3.9 into the B column. Notice A1 and B1 are not containing any information. It's super important that you start your data with A2 and B2. On the left, A is going to end up being my x-axis going across the bottom of my chart. My B column is going to be my y-axis, the one going up and down in my chart. And so, as I'm ready to enter my data, I'm going to highlight by clicking and dragging A2 and B2 and all the way down. I only want to highlight my data. I don't want A1 and B1. I don't want anything after my data highlighted. I just want that highlighted so that whenever I'm ready to press insert at the top, and it gives me all these choices, pictures, tables, I want to come over here to where it says recommended charts, and there's all these different charts to choose from. Please hover over the one that says insert scatter, also called an XY plot. Click on it and you get these different options. And as you hover over them, it changes. I want the scatter plot that's just the dots, the one that just says scatter. Click there. Ta-da, we have our chart. Notice our X and Y axes. X at the bottom is our heights. On the left, our Y is our diameter of our blood. But how do we know that? Well, we need to go in and label our axes. Click the plus button. Click the axis title button. You click there, and now it allows you to edit those titles. So over here, we're going to backspace out of that. You can try to highlight that there, but it's going to have you type right where it says FX as well. So on the left, our y-axis is going to be our diameter of blood in millimeters. Make sure when you do this lab that you measure the drops in millimeters. At the bottom, we're going to change our title, our x-axis, to the height, and we're going to measure that in centimeters. The title of our graph is going to be titled our X versus our Y, so height versus diameter of blood spatter. It's always good to have a chart title is your x versus your y, because everything in the class x versus y is your independent variable versus your dependent variable. In your hypothesis, how does this affect that? That's your testable question. If this happens, then that happens. It's always height, then diameter. So if this is the height, then this is the diameter. Next, we need for Excel to do the mathematical work for us. So we want it to find a line of best fit. We want it to find a slope. We need the y equation. The y equation is the most important part because it's what we're going to use to determine how high Anna's blood fell by using the equation. So hit the plus button again next to it and go down here to trend line. Click it, and what it's doing is it's putting in a trend line. Yours may not look perfectly straight like this, but what we've learned in our pre-lab is as the diameter of the blood drops gets bigger, that tells us that it was dropped from a higher spot. So the really small drops came from a really low location, and the very large drops came from a high diameter or high height. And so what we're going to do for this trend line is we're going to click the little arrow next to it, and we're going to go down to more options. We want to make sure that our trend line gives us a linear trend line, which it does, and scroll down. We want to make sure that we've displayed the equation on our chart. Click there and notice we now have a y equals. Click that and drag it so that you can read it to the top or to the bottom. I don't care where you put it, just make sure we can read it. So for this specific lab, which again is all made up information, it's not necessarily going to be what yours is going to look like. Every group will have a different y equals formula. On the quiz, I'll ask you to be able to plug in height and diameter. So if this is our x-axis at the bottom, x equals height in the equation, y equals diameter. And so if I told you that a drop was 150 in diameter, what would 150 is where it was dropped from. The diameter would be, follow it over, approximately 3.5. That's really easy to do because this is a perfectly straight line when it comes to horizontally. However, when you do your y equals formula, or when I give you one on the test, it's not necessarily going to be perfectly straight. And so you're going to have to be able to plug in y if I give you this number, and you're going to have to be able to plug in x if I give you that number. Remember, in order to figure out x, you have to use your basic algebra skills. Before you close out of this data table, you need to click on the graph. You see how it is selected? You need to control and copy, or right click and copy. Notice when I right click it doesn't let me copy. You have to click down in the right hand corner of it away from all the data, and then you can go up here to copy. Copy the graph. Make sure the y equals is there. Go back into your Word document and paste your graph. Ta-da! Now you have your y equals formula. Let me show you how to figure out the basic math between the y and x. So we know our y equals our diameter in millimeters, and our x equals our height in centimeters. So if I were to say that the drop of Anna's blood was 2.3 millimeters, you would need to plug 2.3 into the y. So your equation would read 2.3 equals 0.01x plus 1.9. I'll zoom in on that so you can see it a little closer. What did I do? I took the information given and I went up here and I plugged in that number into the y. And I kept the rest the same. And then you solve for x to figure out what height the blood would have dropped from. If I give you height instead of diameter, you would put it in the place of the x instead of the y. Now that I have my y plugged in, solve for x by first starting with the plus 1.9. Subtract that, because we have to do the reverse equation to figure it out. Subtract 1.9 from 2.3 and you get 0.4 equals 0.01x. Now to remove the x from the 0.1, the reverse of multiplication is division. So take the 0.04 and divide by 0.01. And you will get 40. X equals 40. We just solved for x, which means if the diameter of the blood was 2.3 millimeters, that means that the height the blood must have fallen from was 40 centimeters. Go on up here and find those two numbers. 2.3 would roughly be right in here somewhere, and 40 would be definitely before 50. So that, you could guess it would be somewhere around this plot, but without plugging it in the equation, you wouldn't be able to tell me the exact number. You will need to know the exact number of the height and of the diameter if I give you questions on the quiz or test that ask you to solve for x. Remember, the y equals formula changes for each question and each group, so make sure you pay attention to it and you know how to solve for x and solve for y.